Hello everyone, welcome to this lecture. In this lecture, we are going to study the rest part of functions, right? So in the previous two lectures, we have already started with functions and we have studied till we have studied the basics of function, right? Then about documentation strings, and also when we execute some function, then how the symbol tables are made, and from where the variables are accessed, right? And how they are searched. So these things we have discussed up to this paragraph, right? So we will complete the rest of the part in this lecture. So here, little bit more detailing has been given for local symbol table only, and that is the about the actual parameters, right? So the actual parameters, which are also known as arguments to a function call, are introduced in the local symbol table of the called function when it is called, right? Now what is the meaning of this? So what is happening that here, this is the called function, right? Who is the called function here? Fib. This is the called function because this has been called, right? So here whatever we are passing, that is 2000, right? So when we are calling it, then what happens? This 2000 value gets passed in this variable n, right? After that, in the local symbol table, this n is included, right? So that means this n is present where? In the local symbol table of the called function, which is fib here, right? This is what is mentioned in that particular statement. Okay, so you can read it again. The actual parameters to a function call are introduced in the local symbol table of the called function when it is called, right? So thus arguments are passed using call by value, right? So how the arguments are passed? By call by value. What is the meaning of call by value? That we call the functions by passing the values. So here, like in the above code, 2000 is the value which is getting passed to the parameter, which is n over there, right? So where the value is always an object reference, not the value of the object, right? Okay. Now, when a function calls another function or calls itself recursively, a new local symbol table is created for that call, right? So this is what you have to understand, that I don't know if you're aware about recursion and all, okay? But if you are having little bit idea also, in recursion, what we do, we call a function again and again, right? We call the same function, the function call itself. Basically, it looks like this, right? That I can, let us say, def fun is there, right? And then inside this, if it is calling itself like this, okay, if this is what is happening, okay, here a lot of changes has to be done, base cases and all we have to add, then it will be the correct recursive program. But overall, the recursive functions look like this, right? That it calls itself, this function is there and it is calling itself from here, right? So again it will get executed, again that function will call itself by this fun, okay, statement. So in this, what is happening? The function is calling itself again and again, right? So in this case, as many times the function is getting called, those many times local symbol table will be made. Okay, those many times local symbol table will be made. So let me just write it one proper recursive function and let us understand. Okay, so here let us say I am writing n. Now if let us say some condition, because this is the base case we have to give where the function will end, otherwise it will keep on going infinitely and that is not a good thing, right? So if n is equal to 0, then what we will say, then we can just print, we can simply print stop, right? And otherwise what we can do, else we can call, else we can first of all print the number n, and then we can call the function again with a new value, that is n minus 1, right? So it is calling itself but with a different value, right? Every time a new value. So after this we can call the function with some number, let us say 10. Okay, now let us execute this. Okay, so here with 10 it has printed. So okay, the screen is not coming completely, so I can just keep it from 5 itself. Okay, so here 5 4 3 2 1, and then finally stop is getting printed, right? So how it is executing? So for function 5 is getting called first of all, right? Fun of 5. After that it is coming here checking the condition, and since n is not equal to 0, right? 5 is not equal to 0, it is coming here. So it is printing n. N is what right now? Right now the value of n is 5. Right. So when this function executed, for before this, what happened? One local symbol table is made internally, right? And there the n value is 5. So that is the local value, okay, in the local symbol table. After that, what is happening? Again, once more, I am calling fun of n minus 1. That means fun of 4, right? Now, when fun of 4 is getting called, right, this is the called function now. So for this called function, one more new symbol table will be made where n value will be 4. Okay, again for 3 it will call, for 2 it will call. So as many times function call is happening, for that one new separate symbol table will be made where the current values are stored. Okay, so that when it traverses back for other kind of recursive functions and all, you can see some programs are there where it has to go back again to that function and do some more tasks. So that means those local states are stored so that you can continue from there, right? So this is how it works, and that is what it is saying, that for recursive functions also, for each recursive call, one new symbol table is made. Okay. Alright, now a function definition associates the function name with the function object. So remember, function in Python, everything is an object. So we have function objects also in the current symbol table. So in the current symbol table, what is there? The function name is also stored in the symbol table. Okay, along with what? So the function name with the function object. So they are associated, the name and object is associated and they are stored. Okay. Alright, now the interpreter recognizes the object pointed to by that name as a user defined functions. Okay, so whenever it sees the object names and all, it understands that it is user defined. Okay, other names can also point to that same function object and can also be used to access the function. Understood? So from this code you can very easily understand. Here like fib is there, if you are only directly printing fib, then what will happen? This particular thing will be printed. Okay, so here what it means, that it is a function object, right? So it is the function object whose name is fib, right? And it is present at which location? At this particular location, right? Every object gets some location in the memory, so this is the location of that. Now since this is also an object, we can have multiple references for the same object, right? So that is why f is equal to fib. That means this is also pointing to the same function object. Okay, f is also pointing to the same, fib is also pointing to the same. So that is why we can call f of 100 also. You see in the code, anywhere if any function has not been created whose name is f, but since in f I have assigned fib, so I can call it similarly like fib only, and the same Fibonacci series will be printed. Okay, so this we can do. So same thing can be done here also. Okay, like here n is there, and something else we can do, that is, okay, so here print n into 2. Okay, so this I'm just doubling the number. So right now if I print it, then what is going to happen? It is printing 10, right? Now if I just print the name of this function, then let us see what will happen. Okay, so here actually I have to write it inside print. Okay, so print and then fun I'm writing of, let us say, 3. Okay, so in this case what will happen? So 6 is printed and then none is printed, right? Actually this none is the return value it is printing. Actually none is printing the return value. So here I did one mistake, that is, when you have to just print the function object and all, then in that case parameters you will not add, right? So that is the mistake I have done, because parameter means I am calling the function. So here we are not calling the function, we are just trying to print the information of this function. So only the name of the function you will write, which is fun. Okay, so now if you run, then you see exactly similar, of course address will not be same, right, but similar kind of output you are getting. So it is a function object whose name is fun. Okay, and at which location it is present? It is present in this particular location. Okay, now what I can do, I can assign some other variable also there. So I am writing temp is equal to fun. This is what I am doing, and let me print temp also now. So if I do this, then let us see what will happen. You see exactly, okay, it is both are function objects, right? And their actual name is what? Actual name is fun, right? So that is why fun, and at which location it is present, since both are pointing to the same object, right? That is why the same, exactly the same address is printed. So by this you can understand they only the names are different, but they are referring to the same object, right? And using this you can also call, so I can call here temp of 100, let us say. So in this case 200 is printed and rest of the things as it is, right? So this is how we can have multiple, I have taken temp, you can take more 5 variables also which are pointing to the same function, right? So it can be done like that. Okay, all right. Now if you're coming from other languages, let us say C++ or Java, something you have learned, right? You might object that fib is not a function but a procedure, since it does not return a value, right? Because if you see here this code properly, in this entire code any return statement is not written, right? So you may say that it is a procedure. We should not use the word function here, we should use the word procedure, because procedures are such block of codes where return statement is not there. Okay, but then still in this entire documentation function word is written, and I also said function in the entire lecture, right? So are we wrong? So we are not wrong, right? And why we are not wrong, that reason has been mentioned here. That is, even functions without a return statement do return a value. Okay, so we are calling it function because although any return statement is not there, but actually it is returning a value. So every function in Python will return definitely a value, whether you are writing it explicitly or not, okay, but it is going to return some value. Now the thing is that if you are returning something, then it is fine, right? That particular value will be returned. But if you have not given any return statement, then what it will return? So it is going to return actually none. This is the value which will be returned, right? So end of the day, what is happening? That something or the other is getting returned, right? Either your value or none. So that means basically every function returns something, and that is why we are calling it function and not procedure. Okay, so I hope it is clear now. So it is what? It's a built-in name, right? It is, this name is already present in Python. Now writing the value none is normally suppressed by the interpreter if it would be the only value written. You can see it if you really want to use okay, print. Okay, so basically what is happening? So here fib of 0 is getting called, right? Fib of 0. Now when fib of 0 is getting called, you see here at first only the condition is becoming false, because first a is 0 and n is also 0, right? So 0 less than 0 is false. In that case nothing is happening, right? This loop will not execute. Okay, and then print. So this is just for next line, right? So that means overall in this function nothing happened, any task did not happen, right? So in this case what will happen? If you print it like this, if you print fib of 0, then none will be printed because nothing happened, so at least none will be printed, right? So that is what is written here. So here also, as I actually by mistake I wrote one code earlier, and there you saw that output was coming none, so that was one example. And otherwise let me show it here. So let us say print I'm writing and fun of, if I don't pass anything then it will be error, right? If I don't pass anything then it will be error like this. Okay, so because here one parameter we are passing and any such condition is not there. Okay, so if I give some condition like if n is greater than 0, then you find double. Okay, and for indentation purpose I'm putting it inside tab. Okay, so if it is greater than 0, then you do something. Otherwise, let us see what will happen. So now I'm giving 0. That means this condition will be false. So any execution will not happen inside this function. So now if I run this, so now you see none is printed, because now inside function nothing happened only, right? Because condition was false, nothing happened, right? Any statement did not get executed. So finally it is printing none. So because that is the value which is getting returned. Okay. So I hope it is clear. Now after that, again for Fibonacci series only, the code is already written, right? But here they have little bit modified it so that you can store the Fibonacci series in a list. So only that much has been done here. So result is equal to one, list has been taken, and then whatever value is getting generated, that is appended in the list. Okay, so that much only has been done. I hope it is clear. Nothing as such new here. Okay, so just here two points are there which are like some new Python features. So let us see that, and then I will end the lecture. So the first statement which we already discussed, that is return statement. So if nothing is there, right, it returns a value from a function, right? Return without an expression argument returns none. So falling off the end of a function also returns none. Okay, if you're falling off out of a function without doing anything, then you will get none, which example we already saw. So that is the first point you have to remember. So every function returns something. If nothing is mentioned, then at least none it will return. Okay, after that, this is one important point which is there. So this they have taken the help of this statement, that is result dot append a, right? So this statement they have explained it. So what is there? The statement result dot append calls a method, and you see this method has been written in italic form, right? They are not saying it function right now, they are using the word method here. Okay, so it calls the method of the list object result, right? So what is a method? A method is a function only. Okay, a method is a special type of function that belongs to an object. Only this is the difference here, that belongs to an object. That means with some object reference only we can call that function. If it is like that, then then that particular function we will call as method. Otherwise it is simple function. So what it means, that here you see, for calling this fib, right, like this fib2 is there, we are not associating it with any object, right? Independently we can call it. So in this case it is function. But for this append, if you directly write now append of a, if you are only writing this much, then it will not execute, you will get error. Okay, because always this append function you have to associate with list object, and that is why this append function we call it method. Okay, it is a function only, but it is a special function because it is associated always with an object. So the special name we use, that is method. Okay, so I hope it is clear. That is why this point has been elaborated so much. Okay, it is crucial to understand this. Okay, so I hope it is clear now. A method is a function that belongs to an object and is named like this. Okay, so like this you will write the name. So object name you will write, then dot, and then whatever method name is there. Okay, so example is written right over here, that is result is the object name. Okay, after that dot is there, and then method name, okay, is written. Now different types define different methods, right? If different types are there, you see here object itself is a type, you know, type because classes are some types. Okay, objects are instances of classes only. So if you're not having any idea about classes and object, it is okay, you can skip this part. But otherwise those who are having idea, you can understand that classes itself are like types. Okay, so that is why when we call with different objects, that means we are calling it with different types. Okay, so in that case, it will define the methods in a different way. Okay, so methods of different types may have the same name without causing ambiguity. So it may happen that different objects are there, obj1, obj2, obj3, right? And all are calling a method which is having the same name, but still any ambiguity will not happen because the objects which are calling them are different. Okay, although method names are same. All right. So now it is possible to define your own object types and methods using classes. So about classes we are going to study in upcoming lectures. Now the method append shown in the example is defined for the list object, right? So because we are calling it method, that means it is associated with some object, right? Now which object? So it is associated with list object. Okay, so what is the purpose of this? Actually it adds a new element at the end of the list. Okay, so remember at the end only it can add. Okay, not at the beginning, not in the middle. So actually it works very similar to this. In this example it is equivalent to result equal to result plus a. Okay, so if any list you are having and in that like this you are adding some element, okay, then the purpose is same, that the element will be added in the last. But if you are using this method, then more efficiently it will be done because internally these are implemented in a very efficient manner. Okay. So this was about today's lecture. Please read this documentation by yourself also. And here I'm ending the lecture. Thank you.